Hello and welcome to the Algebra 2 Test 3 Study Guide. My name is Mr. Sipple, and over the next hour or so we're going to go over the 10 problems that you'll find on the Quadratics test, solving and graphing quadratics, and each one of the questions here matches up almost identically or exactly to one of the questions, or each question rather I should say, that you find on the test itself. So to go ahead and get started, first of all let's just make sure you got your name on your paper. We want to make sure we give you credit for being here. So go ahead and write your name, top right corner of the page there. And before we actually start working a problem, I just want to kind of go over a couple things, just kind of some big ideas that we're going to cover in this video. We're talking about quadratic equations, and we're going to do two things with quadratic equations. We're going to solve quadratic equations, and we're going to graph quadratic equations. The first part of this is that by solving a quadratic equation, we really do it in one of two ways. We can either solve it by factoring, which is the first choice there, or we can solve it by using the quadratic formula. Now, factoring is listed first because, to be honest with you, factoring really is kind of shorter. It's a little bit less work. Or at least that's my opinion, and I think most people share that opinion, that if you can factor something, then you want to try to factor it first. Quadratic formula, the nice thing about the quadratic formula is it works for every single problem. So there are some problems where factoring actually does not work. You actually cannot factor it. However, quadratic formula will work for every single problem. Downside of it is that there's a little more work involved. There's a lot of little calculations, maybe more places you can make mistakes. So that's why we try to factor things first. And so actually on the first problem, we're going to start by factoring. Other thing just to mention to you real quick as far as how these questions might be worded. So and write this down here. Solutions equals x intercepts equals roots equals zeros. And all that means is, and when they say what are the solutions, they might also say what are the x intercepts. So what that means is that when you solve a quadratic equation and you say x equals this and x equals that, what you're saying is you're saying that's where the parabola, the graph of that quadratic equation crosses the x-axis. And we'll look at a couple on a graphing calculator here in a second to clarify that. Now the other theme of this test is to graph quadratic equations or quadratic functions. And we're really going to do that in two different ways. The first way is that we'll see some that are in vertex form, and vertex form just refers to a form in which we can really just look at it and we know what the x and y of the vertex is, and therefore make a sketch of the graph from there. However, it's not always going to be in vertex form. We'll look at a couple that are in standard form, which is this form right here, where you actually have to use a formula to figure out what the x is. Once you know x, then you can plug it in to figure out y. So we'll look at a couple there. So that's just kind of a preview of what we're going to be covering in this video, solving quadratic equations and graphing quadratic equations. Alright, well, let's go ahead and get in there. So let's take a look at the first problem. So it says, what are the solutions to the equation 5x squared minus 7x minus 6 equals 0? Alright, well, so there's a couple things that we want to check for first before we actually do anything. And this is actually going to be true for whether you're doing a quadratic equation, solving it by factoring, or the quadratic formula. There's something we're going to want to check here first, which is we want to check for standard form. Basically, all that this is going to mean is that everything is on the left, right? So all the numbers, all the variables, all the exponents, everything is on the left side, and then equal to 0 on the right side. And you're wondering maybe what's Beyonce doing up there? Well, so that's our Beyonce rule, is that for something to be in standard form, everything is to the left, to the left, to the left, to the left. Now in this case, it actually is in standard form. Everything's on the left, so we're okay. Now, so let's try to factor it. And at this point, I'm assuming that you have seen this before. So, you know, this big X, this isn't anything new to you. This is just a little tool that we use to help us factor. What we're doing when we're factoring is we're trying to say, what did this look like? 5x squared minus 7x minus 6. Two things got multiplied together to give us that. We're trying to figure out what were those two things that got multiplied to give us those two things. Now you see the letters A, C, B, so you're like, what's all of that? Well, remember here is that standard form, the A is the number that's in front of the x squared term. So this would be our A. The B is the number that's in front of x, which would be negative 7, and then the c, which is the last number there, which would be negative 6. So there's our a, b, and our c. So a times c would be 5 times negative 6, which would be a negative 30. Now the b that's on the bottom, negative 7, all right. And what we're looking for is we're looking for two numbers that would multiply to the top, and then we want those same two numbers to also add up to the bottom as well. So to multiply to the top, add to the bottom. So you start thinking about the multiples of 30, different ways you can multiply to 30. Of course, 1 and 30, but that won't make 7. Maybe 6 and 5. It's 11, 1. Oh, okay. How about 10 and 3? So let's try 10 and 3. Now, 10 times 3 is a positive 30. We need a negative 30, so we know that that means that one of these signs needs to be negative. Then the question becomes, well, I don't know. How am I supposed to know which one to make negative? Well, look at the bottom. So this is that there's a negative 7. There were 7 negatives left over when you added these two numbers, whatever these two numbers are. Well, if there's more negatives left over, that must mean that there was more negatives to begin with. So that would have to be a negative 10. Okay. Excuse me. So what we have to do is then take those numbers, x minus 10 and x plus 3, and put those in parentheses. And we're still in the process of factoring it, so we're almost there. There's actually kind of one last step to this, is that we have to divide by a. Now, when we say divide by a, it's the a that was here in the original problem. Why are we dividing by a? Well, you know, one kind of maybe easy way to think of this is from the very beginning of the problem, we multiplied a times c. So now we're kind of backing that out, doing the opposite. So now we're going to divide by a. So I'm going to divide by a, which again in this case was 5. So divide by a, and then what we'll want to do is we want to divide these numbers. So for instance, negative 10 divided by 5, which would be a negative 2. And then you look at something like 3 and 5, and you're like, well, that actually doesn't divide evenly. Well, that's where Beyonce's got another little reminder for us here. She says, if you can't divide it, slide it. Yeah, there you go. All right. So x plus 3, right, so you're going to slide this thing in front. That was really bad. I apologize. So 5x plus 3 equals 0. So what I now have is I now have it factored. What I have to do from this point is that I just have to separate and solve it. And what we mean by separate and solve is that I need to pull these two things apart, because you're trying to solve for x, right? But you got an x here and you got an x there. So you have to create two separate equations so that you can solve for x. So this would be x minus 2 equals 0. And by the way, this will always be equal to 0, because what we're saying is we're saying this group times this group is equal to 0. Well, if two things are, when multiplied, equal 0, that means that one or both of them would have to be equal to 0. So we will always set this equal to 0. And because from the very beginning we made sure that it was in standard form, that there was a 0 right there. So that will always be the case. And then we're just going to solve each equation. So let's add 2 to both sides, so we get x equals 2. And then for the other equation, subtract 3. So you get 5x equals negative 3. Let's divide both sides by 5. And again, it's a fraction. That's okay. So don't think you made a mistake just because you got a fraction. That can happen. And then so what we'll do is that those will be our two answers there. So we'll have, and I'll just kind of write this over to the side. So you would have x equals 2 and x equals negative 3/5. Now, so remember in the very beginning I mentioned that solutions, when they want you to solve it, it's really the same thing as just saying, hey, what are the x intercepts? So if we were to graph this parabola, for instance, and let me just pull up my graphing calculator here. All right. There we are. And so if I graphed it, right, so the equation we were working with was 5x squared minus 7x minus 6. So if I graphed this parabola, you'll notice that the parabola, it might be kind of hard to see, but you see where the parabola touches the x right there? That's 1, and that's 2. So when we say that x equals 2, what we're saying is that's where the parabola touches the x-axis. You notice the other one, x equals negative 3 over 5. You know, 3/5 isn't quite one whole, so that point right there would be negative 1. So a little bit before that would be a negative 3/5. So again, that's the connection between solving the equation and then the graph of that particular equation. Alright, so now go ahead and pause the video here. I want you to try number 1 in the middle, pretty much exactly the same thing as this. So try number 1 in the middle, and then once you feel like you have the answer, go ahead and restart the video and we'll check the answer to that particular problem. Again, make sure that you've done number 1 in the middle at this point, because in about a second I'm going to flash the work and the answer for you so that you can check your work. Okay, so for number 1 in the middle, you should have got x equals 2 and x equals negative 1/3. Now, if you got that answer and you got that correct, then you can go ahead and fast forward to see the answer for number 1 on the right side. If you did not get that correct, I'm going to talk through the solution on this one. So again, if you got the answer correct, you can go ahead and fast forward to see the next problem, or number 1 on the right side, I should say. But if you did not get this one correct, I'm going to work through this problem with you so that we can figure out maybe where you made a mistake. So remember, a times c on the top, b on the bottom. So here's your a, b, and c. It's always just in that order. So a times c would be 3 times negative 2, which would be a negative 6. And on the bottom, two numbers that multiply to negative 6, and that would add up to negative 5. So 2 and 3, and this was kind of tricky. 2 and 3 multiplies to 6 and adds up to 5, but we're trying to multiply to a negative 6. So, one number that we always tend to forget, 1 and the number we're looking for. So if we're looking for 6, it would be 6 and 1. And by the way, I didn't mention this in the other one, but I do want to mention this here, is the order doesn't matter. So if you put 6 and 1, 1 and 6, whatever, it's the same difference. And then which one do I need to make negative? Well, I have more negatives left over, so that means that the bigger number would have to be negative. So that would have to be a negative 6. All right, so let's write those, our factors. X minus 6 are what's going to become our factors, and x plus 1 equals 0. And so again, we have to divide by a. So in this case, again, our a is 3. So we're going to divide by 3, and we get x minus 2. Can't divide it, so slide it. So let's slide that 3 over, so that becomes 3x plus 1 equals 0. And then at this point, we're just going to separate and solve, right? So we're going to solve each one of our equations for x. So let's pull these two things apart. So x minus 2 gets his own equation, so x minus 2 equals 0. And then 3x plus 1 gets his own equation. So let's solve each one, similar to the last one, add 2 to both sides. So we get x equals 2. And subtract 1 from both sides, just trying to get x by himself. Divide both sides by 3. And again, get a fraction. That's all right. So the 3's cancel each other out, and so you get x equals negative 1/3. And x equals 2. All right, and so let's see. Now you should have also done number 1 on the right side. So if you haven't done number 1 on the right side, go ahead and pause it now. If you have already done number 1 on the right side, then we'll go ahead and check the answer for that one. And checking number 1 on the right, should have got x equals 4 and x equals negative 5/2. So if you got that correct, great. Let's go ahead and go on to the next problem. If you did not get that correct, take a moment, try to figure out maybe what your mistake was, rework the problem. A lot of times it's just little stuff. Maybe a mistake with the sign, multiplied wrong, added wrong. Those kinds of little things. So just be careful with that. Also, I just wanted to show you the graph on this one real quickly. Right, so if we're saying that x equals 4, take a look at the graph. 1, 2, 3, 4. Right, so the parabola is crossing the x at 4. And then negative 5/2. Negative 5/2 is almost negative 3. So you see negative 1, negative 2, and almost negative 3. So that's the other place where the parabola crosses the x-axis. All right, well, so let's go ahead and take a look at number 2. So number 2 says, what are the solutions to the equation? Oh, and there's Beyonce. She's back telling us to the left, to the left. All right, now, so is everything on the left side? Well, you look at it, and I don't think that's going to be in standard form. I don't think Miss Beyonce is going to be very happy with that. So let's see what we would have on this one if we got that into standard. Now, as we can see, it's not, the equation that is not equal to 0, so we need to make it equal to 0. Well, what I could do is I could take the number that's there, 4, and I can move it on over. Now, how do we move stuff in algebra? We do the opposite. So the opposite of adding 4, or a positive 4, would be a negative 4, and let's do that to both sides. 4 minus 4, which cancels each other out, which is what we wanted to happen. And then let's write what we have left here. So we've got x squared minus 4x, 12 minus 4, which would be 8. All right, so there we go. And I can label my A, B, and my C. By the way, if you're like, hey, what's the A? Well, there's always a 1 in front, right? So if you don't see it, the coefficient, it's implied or understood that that would be a 1. So there's your A, there's your B, and then here's our C. All right, now we said in the very beginning you could try to factor things first, and then if that doesn't work out, you can use the quadratic formula. So let me just show you something real quick, because we're actually going to use the quadratic formula on this particular problem. Now, you don't have to write this down. I just want you to see what would happen if we tried to factor it. So if we tried to, so A times C, which would be 1 times 8, which is 8, B, which is a negative 4. And so if you tried to factor it, two numbers that multiply to 8 that add up to negative 4, well, you could try 1 and 8, but that wouldn't add or subtract to negative 4. You could try 4 and 2, but 4 plus 2, 4 minus 2, that also wouldn't add up to negative 4. So in this case, there's actually not two numbers. This actually cannot be factored. So there's actually not two numbers that would work in this situation. So that's where we're not going to use factoring. So that's where we're going to use our method of the quadratic formula. Now, what I would have is that I'd have the quadratic formula written down. I should have already written that down on your paper. The reason I say that is because I don't want you to have to try to do this from memory. Have it written down so that way you can look at what you have and then plug the numbers in from there. Now, one way that I do this, and you don't have to necessarily do it the way that I do it, but for me, it's a way to kind of organize the work that's maybe a little bit less work. What I would tell you to do is that from where you're at, where you wrote A, B, and C, skip down about 4 or 5 lines. So you see, I'm going to skip down to here. And what I'm going to do, I kind of call this a wedding cake, birthday cake, I don't know, whatever kind of cake you want. And what I'm doing is I'm going to plug in, see, I'm going to write the formula negative B. B is negative 4. And I'm going to kind of color code this for you so that you see which numbers are going where. And then it says plus or minus, so I'll copy that, plus or minus. And then it says the square root, so I'll draw a little square root. And then it says b squared. Well, again, we said that b was negative 4. So let me put in negative 4. And then it says minus, so I'll write a minus. Then it says parentheses 4 times A times C. So 4 times A, which would be 1. So times 1. And then times C, which in this case is 8. So times 8. And then close off the parentheses, and then that's all divided by 2A. I didn't have it queued up, but one way to remember the quadratic formula is by the medley of the music to Pop Goes the Weasel, right? So it goes a little something like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I promise that'll be the last time I sing. No more singing, I'm cut off. All right, so let's simplify what's underneath. And by the way, we maybe should define one thing here. The square root symbol, the fancy math word for that is the radical. Maybe make a note of that somewhere, because we're going to be using that word radical, and so I want you to know what I mean by that. Because it's not always that you're taking the square root of something. You could take a cube root, right? So there's other roots. So yeah, we call that the radical. And then so what I'm going to do is I'm going to simplify what's underneath the radical. Now that says negative 4 squared. Not negative 4 times 2, but negative 4 squared, which would be negative 4 times negative 4, which would be a positive 16. By the way, this first number will always, 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 always be positive, because when you square something, it would be a positive. Minus 4 times 1, which is 4, and then 4 times 8, which is 32. So I've got 16 minus 32. I've got more negatives, so my answer would be negative, and then negative 16. Now, this is what sets it apart from Algebra 1. In Algebra 1, if you got here, we told you the answer was no real solution, and then you put no real solution or no solution, and then that was it. However, in Algebra 2, we have a way around this by using imaginary numbers, because when you think about, when you're taking the square root of something, you're saying what times itself would give you the number underneath. Well, and then maybe you think, oh, well, so it's a negative 16, that would be a negative 4. Well, but negative 4 times negative 4 would be a positive 16, right? So you actually cannot do that. So what we're going to do is we're actually just going to go to the side, and I'm just going to do a little factor tree with negative 16. And what I'm going to do is that I'm going to separate out, first of all, I'm going to separate the positive part from the negative. You see, the negative is the problem. I can take the square root of 16, that's fine. I just can't take the square root of a negative 16. So what I did is I separated the two. I've got a positive 16, or square root of 16, and then square root of a negative 1. Well, the square root of 16 is 4. And just 4, right? Not square root of 4. And don't break this down further, right? The whole idea of breaking this apart is that we're just looking for a perfect square. So 16 is a perfect square. So I don't need to keep breaking this apart by saying 4 and 4 and 2 and 2. So don't do that. You're just breaking it apart until you find something that's perfect. And then the square root of negative 1, as we have noted over here, is we could write 4 times the square root of negative 1, but this imaginary number, the square root of negative 1, comes up a lot. So instead of having to write square root of negative 1 all the time, we actually have a letter that represents that, right? It's kind of like pi, for instance. Instead of writing out all the numbers 3.214, writing out all the numbers for pi, we have a symbol that represents it. So kind of the same idea here is we have a symbol that represents the square root of negative 1. Really easy way to remember that? Square root of negative 1 heart math, right? That means that you I heart math, that's what you're saying there. So square root of negative 1, which would be I. So we'd have 4I on the top of our little wedding cake there. And again, this was just a little side work for us, doing a little factor tree to figure out what that would be. And the whole reason we do that, by the way, is because we want to get to the end here and we want to see if we can simplify or reduce this. So positive 4, and again, why is this a positive 4? Let's go back to the very beginning here. The negative and negative would make a positive 4. So that'd be positive 4 plus or minus, and then what we have on top, which would be 4I. And actually, I'm going to use my highlighter here real quick, because I just want you to see, what is it that actually makes it over to the answer. So whatever makes it over to the answer is what was in front, so there's the positive 4. Whatever is on top, so in that case 4I, and then whatever was on the bottom. And all this stuff that I didn't highlight, that was just the kind of our work to getting to the answer. But as far as what we write, it's just what's out front, what's on top, and then what's on the bottom there. So 4 plus or minus 4I over 2. And then what we want to ask ourselves is, well, can we reduce this? Because this is a fraction. I know it looks kind of weird, but it is a fraction. As if with any fraction, you want to see if you can reduce it. So, well, yeah, you can divide all of those by 2. So let's divide all of those by 2. And let's see what we would get there. So if we divided by 2, divided by 2, and I'm just writing this so you see how I'm reducing that. Certainly you could do that mentally if you wanted to. So 4 divided by 2 would give you 2. 4 divided by 2 would give you 2I. And then 2 divided by 2 would be 1, but anything divided by 1 is just itself, so we actually don't have to write the over 1 part of it, so we could actually just leave our answer that way, which would be 2 plus or minus 2I. Alright, so pause the video now, try number 2 in the middle, and then once you have number 2 in the middle complete, go ahead and hit play again, and then we'll check the answer for you. Okay, so the answer for number 2 in the middle is 2 plus or minus I. And if you got that correct, great. Go ahead and pause the video now and try number 2 on the right side. If you did not get that correct, then we'll go ahead and work through number 2 in the middle together so that we can maybe try to figure out what mistake you made. But again, if you got it right, go ahead and fast forward to see what the answer for number 2 on the right side would be. All right, so as far as number 2 in the middle, again, we got to check for standard form. So we're wanting to see, okay, is this in standard form? This is not. It's very similar to the last problem. So I got a -7 that I've got to move over. So the opposite would be to add 7. So let's add 7 to both sides. Right, those cancel. And then I've got x squared minus 4x plus 5. And then that's equal to 0. All right, so let's label our A, B, and our C, because you got to make sure you get the right numbers in the right spot. So there's your A, and here's your B in the middle, and then, of course, 5 would be your C. Again, skip down a couple lines here, so we'll skip down here towards the bottom. So I've got x equals -b, which, again, in this case, b is a -4. And by the way, you don't, on that last one, I kind of waited to the very end to do these two things. You don't have to wait on that, right? If you see right away the negative and negative, go ahead and change that to a +4. You can do that. Also, some people look at it and they say, okay, well it's -b, so if it's a -4, that means it's going to be a +4. So you could also write it that way as well. So there's a couple different ways you could do that. All right, and again, what I'm doing is I'm looking at my formula over here. So I'm not trying to do all this stuff off the top of my head. I'm looking at the formula and I'm just copying it down. So plus or minus, extend my fraction out there, the square root of b squared, which in this case, again, our b is -4, so that would be -4 squared, minus 4 times a, which is 1, times c, which is 5. And again, I'm color coding this for you so you could see, you know, what I'm writing in black, that's the part of the formula that's always there. The colored numbers, right, for 1 and 5, well, those correspond with your A, B, and C. And then that's all over to A, which, again, in this case, A is equal to 1. All right, so let's simplify what's underneath the radical. -4 squared, which would be 16, because, again, -4 times -4, minus 4 times 1, which would be 4, times 5, which is 20. So 16 minus 20, again, you have more negatives than positives, so the answer would be a -4, not a +4, but a -4. Similar to what we did on the last one, we'll go to the side and just do a little factor tree on the square root of -4. Again, we cannot take the square root of a negative number, so the first part of this is always going to be to separate out the positive from the negative. So for the +4 and the -1 there. So square root of 4, which would be 2, and as we've already said, I heart math, square root of -1 heart math. So square root of -1 is equal to I, so that would be 2I. And again, this was just our little scratch work to figure out how to simplify this part of it. And let's carry this over to our final answer. So again, it's what's out front, what's on the top, and then what's on the bottom. So what I would write is 4 plus or minus 2I over 2. And then again, I want to see if I can reduce that or not. I can. Similar to the last one, we can divide everything by 2. So we'll divide by 2, divide by 2. And again, you could do that mentally. You don't have to write it out. I'm just showing you what I'm doing there. So 4 divided by 2, 2. 2 divided by 2, which is 1I. But you know, 1I is just really the same thing as I. It's kind of like x, right? Like if you had 1x, you would just write x. And then 2 divided by 2, which would be 1. And so 2 plus or minus I would be our final answer. All right, so go ahead and pause the video now. Try number 2 on the right side. See what you come up with. And as with all of the problems, the right side problem, I'm not going to work out, because what I want you to do is if you didn't get that one, then you need to ask for some help. So go ahead and pause it now. Try number 2 on the right side. All right, well, welcome back. Let's see what you got for number 2 on the right side. So it should have got x equals 3 plus or minus 2I. A lot of mistakes that get made here is, again, people forget to try to put it into standard form. So you should have had x squared minus 6x plus 13 as the numbers that were going into your formula. The other thing is I wanted to relate it back to the graph. So when we say there's no real solution, because we were saying earlier that x equals where the parabola touches the x-axis, then you look at it and you're like, well, I don't know, how's How does it touch it I? That doesn't even make any sense. Well, if you looked at the graph of this particular one, I'll go ahead and graph that, you notice that the parabola actually does not touch the x-axis at all. The x-axis is up here, and the parabola is floating above the x-axis. So when we say that there's no real solution, what we're saying is the parabola actually does not touch the x-axis. So that's why we say no real solution. Now there is a solution to this, it's just imaginary, right, because it actually doesn't touch. So again, we just wanted to relate that back to the graph. Alright, so now again, if you didn't get this one correct, take a moment, see if you can figure it out on your own. If not, I'm in the room here with you that I can help you figure out maybe what your mistake was. But I don't want you going on to the next problem until you know exactly the right answer and why it's the right answer. Alright, so let's go ahead and move on to the third problem. So this one says, it looks really kind of the same as the last one. What are the solutions to the equation? Maybe the only thing that looks a little different here is, again, it's not in standard form, so we're going to have to do something a little different here with getting it into standard form. So let's add 2 to both sides. Now here's the deal. I'm adding a positive 2, and that's a 2x. Those two things are not like terms. So what I cannot do is I wouldn't want to put, let's say, plus 2 right underneath that, because I can't combine x's with numbers. So what I'm really doing is I'm adding 2 to this side, but the way that I want you to think of it as is that really we're trying to squeeze that 2 right there into that spot. Right, so what this would really be is it would be 3x squared minus 2x plus 2 equals to 0. Again, if you wanted to, you could try to factor this. I'm just going to kind of go to the side here and see if I could factor it. I'm going to tell you right now you can't, but I just want you to see, why we use in the formula. A times c, 3 times 2, which would be 6. Your b is a negative 2. And you're looking for 2 numbers that multiply to 6 that add up to negative 2. 1 and 6 won't make 2. 2 and 3, that would not add or subtract to negative 2. So again, this is an example where factoring doesn't work. Factoring doesn't work for all problems. So we know our backup plan is going to use the quadratic formula, so let's go ahead and use that. And let me get out my eraser. Erase that because we are not factoring. We are using the formula. And again, I've got the formula over here just so I can look at it. And first of all, let's label our A, B, and our C. And and by the way, you might be thinking like, isn't this really just the same thing as what we just did? Well, yeah, actually it is. The only thing that was a little bit different as far as how it was not written in standard form, so that looked a little bit different. And there actually is going to be something different about this problem. The thing with quadratic equation is that you don't know what's going to be different until you get in there. So a lot of them at the very beginning are going to look the same. It's just that once you get in there, you realize, oh wait, there's something different. So x equals negative b. Now we're going to have our big fraction here. So b in this case, which is a negative 2, plus or minus the square root of b squared, which again is negative 2. I've already established that. Minus 4 times a, which a in this case is 3, times c, which in this case is 2. And then, of course, that's all over our most fun part, right? All over 2a. Right, so again, a is 3. Oh, I lied. I said I wasn't going to say it again. Sorry about that. All right, so let's start building our cake. Negative 2 squared, which would be 4. 4 times 3, 12. 12 times 2, which would be a 24. So 4 minus 24, again, there's more negatives. So that would actually be a negative 20. Now, on the last problem, on number 2, you got here, and this was actually a perfect square. 20, however, is not a perfect square, meaning that if you take the square root of it, it's not going to be a whole number. It actually would be a decimal. Well, let me go to the side and do some scratch work. Kind of move this out of the way. And let's take negative 20. I need to break this thing apart. So, same thing, whether it's a perfect square or not, the first thing you got to do is separate out the positive from the negative. So that's always going to be the first thing you're going to do. So I got the positive 20, and then I've got the negative 1. Now, what I want to do is I want to break apart 20. 20 is not a perfect square. So, but what I'm thinking is that if I break it apart, I can find something underneath that is. So, in breaking it apart, I'm not going to do 2 and 10, well, because 2 and 10 aren't perfect squares. How about 4 and 5, right? So you want to pick the pair that has a perfect square, right? Pick the pair of numbers that when you multiply them, you have a perfect square. Now, we already established that the square root of negative 1 is equal to I. So square root of 4, which is 2, just 2. Now, don't do this. I see too many students do that, but they just keep breaking it apart. No, you're not breaking it apart because 4 is a perfect square. Also, notice that there's always a radical on here. The radical only comes off once you find something that is a perfect square. So square root of 4, which is 2. And then that I gets written, because he's outside the radical, so he gets written. And then 5, he's not a perfect square, can't break him apart anymore, so that's as far as you could take it. So you would have 2I radical 5. So again, the parts that make it to the final answer, and again, what we could have done here a long time ago is make that a positive 2. So what makes it to the final answer here, you got positive 2, 2I radical 5, and then 6. So let's go to our final answer here, which would be 2 plus or minus 2I radical 5 over 6. And then what we want to see, same drill, we want to see if we can reduce this at all. I'm looking for a number that goes into 2, 2, and 6, which would be 2. I can divide that by 2, that by 2, and that by 2. And so let's see what we get there. So 2 divided by 2, which would be 1 plus or minus. Now, 1I is really just the same thing as I, so I radical 5. And then that would all be over 3. All over 3. And again, if I wanted to graph this, and I've actually already got it loaded into the calculator for you, if I wanted to graph this, 3x squared minus 2x plus 2, what we're saying is that there's no real solution. So what we're looking for is a parabola that would not touch the x-axis. And if we graph that, we see that it does not touch. It dips down, but it doesn't quite touch the x-axis. So again, that's why we would have no real solution, just simply an imaginary solution. All right, well, so that time again to try number 3 in the middle. So go ahead and pause the video now and try number 3 in the middle. However, if you're ready, let's go ahead and take a look at number 3 in the middle. So for number 3 in the middle, you should have got an answer of negative 1 plus or minus 2I radical 6 over 5. If you got that as an answer, great. Go ahead and move on, try number 3 on your own, and then we'll be back in a second to check number 3 on the right side. However, if you didn't get an answer of negative 1 plus or minus 2I radical 6 over 5, stay with us and we'll actually go through it together, and we'll, again, hopefully try to figure out where your mistake is. So, again, checking for standard form, which it is not, right? Again, Beyonce's telling us everything to the left. So what I would have to do is I would have to add 5 to both sides. And again, those are not like terms. I'm trying to line it, I'm not lining it up exactly. I'm trying to show you that I'm putting the number there at the end. So 5x squared plus 2x plus 5 equals 0. Again, if you tried to factor this, there's not two numbers that multiply to 25 that add up to 2. So that's how we know that we're using the quadratic formula. So again, let's label A, B, and C. There's my A, 2 is my B, and then 5 is my C. Skip down a couple lines so we can make our cake. So I've got negative B, which in this case is 2, plus or minus the square root of B squared, which again B is 2, minus 4 times A, which is 5, times C, which is also 5. And I imagine, by the way, if you're at this point, you probably feel pretty good with this part of the formula as far as getting all the numbers in there, setting it up. Where most people struggle is at the very end of it, where you have to break apart the radical. So that's probably the tough part for you. So let's get there, and then we'll see. But again, it's important. You want to make sure you get all the numbers filled in into the right spot. All right, so let's simplify here. So 2 squared, which would be 4, minus 4 times 5 is 20. 20 times 5 would be 100. Again, more negatives, so you'd get negative 96. And I'm guessing if you struggled with this one, this is probably where you had a little bit of difficulty. So let's go to the side. We'll do our little scratch work where we're going to take square root of 96 and we're going to pull this thing apart. Well, as always, we said the very first thing that you want to do is that you make sure that you pull it apart. Pull apart the positive from the negative. You have to separate that because we can't work on a negative 96. I can work on a positive 96, just not a negative 96. Now, 96, you look at that and you're like, I don't know, like what times what makes 96? And that's probably what was a little more challenging for you on this one, was having that larger number. Well, so I don't know. What I would tell you, and there's actually, I'm not going to show you the quickest way to do it. I'm going to show you the way of, what if I can't think of how to break this apart? Well, you know, any even number you can always just cut in half. So if the number is too large for you, I would just tell you to cut it in half. So half of 96 is 48. And then, of course, you know, square root of negative 1, which would be I. Now, 48, you can actually break that apart with something that is a perfect square, which would be 16, because 16 times 3 would give you 48. And then I'm going to bring the rest of this stuff down. I've got square root of 2, and then I've got an I. Well, we know that the square root of 16 is 4. And then square root of 3, it's not a perfect square. Square root of 2, same thing, not a perfect square. Can't break it apart further. So what happens is that we would actually put those two things back together. We're going to kind of just clean it up. We're going to put those two things back together. And again, we're multiplying here. So that would be 3 times 2, which would be 6. And then I've got the I out front there. So what I would end up with there would be 4i radical 6. That would go on the top of my cake. So again, just to get my highlighter out to show you what's going to make it to the final answer, we've got negative 2, 4i radical 6, 2 times 5, which would give us 10. So let's go ahead and write that. So I've got negative 2 plus or minus 4i radical 6 over 2 times 5, which would be 10. And now I want to reduce, as I've done on the others. So I'm going to divide by 2, and then divide by 2. So negative 2 divided by 2 is where we got the negative 1 from. 4 divided by 2 is where we get 2i. And 10 divided by 2, which is where we get the 5 from. By the way, what's on the inside of the radical, we can't get to that. So you might have thought, hey, well, why didn't you do that divided by 2 as well? Well, again, it's only what's on the outside of the radical. And this has to be a package deal. You have to be able to reduce all of them. You can't just pick and choose which ones. So you'd have to be able to do all of them. All right, well, so hopefully you got that one now, or maybe understood where you went wrong. So go ahead and pause the video now and try number 3 on the right side, and then we'll be back in a second to check your answer. All right, so go ahead and pause the video now. All right, welcome back. So let's go ahead and try number 3 on the right side, or at least let's check what you got for an answer. So should have got x equals 1 plus or minus I radical 11 over 3. And, you know, make sure you had that set up correctly. Standard form would have been 3x squared minus 2x plus 4 equals 0. So 3 was your A, negative 2 was your B, and then 4 was your C. So if you got that one correct, let's move on to number 4, which you'll need to turn your page over. If you did not get this one correct, again, take a moment, see if you can figure out what your mistake was. And if you're struggling with figuring out where you went wrong, then go ahead and ask for some help. Otherwise, we'll go ahead and take a look at number 4. Well, so we're going to take a break from solving. So those were 3 questions in a row that involve solving. Now over the next couple questions, we'll want to talk about the graph, because again, we talked about there really being 2 themes, solving these things and then graphing these things. All right, so vertex form, and what's nice about vertex form is that you don't have to really do any work. It's kind of like telling time. You know, as you look at a clock, and as long as you know what the hour hand means and the minute hand means, you can tell time. So as long as you know what that number means and that number means, and actually that number as well, then you'll be able to come up with the right answer here. All right, so what we're going to do is that we're going to take the first one. It says describe the translation. A translation is just a movement. of something, at least within math. Describe the translation of the graph, and it tells you y equals -2 times x minus 2 squared minus 3. All right, so what I want to do is I'm actually just so we can kind of spread out here a little bit, I'm just going to rewrite that. And this is what I'm doing is I'm actually starting at this parabola, because what's going to happen is they're going to say, okay, if you start at this parabola and then you go to this parabola, and by the way, parabola, I don't know if we've formalized that yet or not, but parabola is just the name of this shape, right? So this U-shaped thing, that's what we call a parabola, right? Because everything in math has a name. Square is a square, circle is a circle, triangle is a triangle. So a line's a line. This particular shape we call a parabola. All right, so what we're saying is if you started at this parabola and then you moved over to this parabola, how far would you go? So what I would do with that is I'm saying if I started here and then I end up here, and I'm just going to write down the other parabola. So y equals -2 times x minus 5 squared plus 1. All right, so here's the deal with the vertex. So the vertex says that whatever's on the inside, the number that's on the inside with x, that's the x value of your vertex. The number that's at the end there, the k value, that's the y value of your vertex. So the h value is your x, k value is your y. Now there is one little thing here, is notice that what it says is that it's actually the opposite of h. Right? So whatever h is, you actually have to take the opposite. So what that means is that when I actually go to write my x and my y, is that I would actually have to take the opposite of that number. I'm just going to do OPP for opposite. So that actually would be a +2. Now this number stays the same. So the -3 stays the same. So my starting vertex here would be 2, -3. 2, -3. And so in a starting vertex of 2, -3, so I'd go over to the graph, 1, 2, down 1, 2, 3. And then so there would be my first parabola. And then the other thing that I have to look at is if you look at this right here, it says up or down. So that's what A tells you. So if that first number is positive, then the parabola is going to open up. If that first number is negative, the parabola is going to open down. Well, if you take a look here, that's a -2, so that means that I'm going to have a parabola that opens down. So I've got something that maybe looks like that. And again, this is just a sketch, doesn't have to be perfect, just a sketch. And so that's where I start. And I'm just going to indicate that this is my starting parabola. Start. And then let's find out the vertex for this other parabola. Again, you have to take the opposite. This becomes the opposite. So this would be the opposite of a -5, opposite, which would be a +5. And then, again, the k value, the last number, that one just stays the same. So +1 would stay the same. So that would be the same. So that means that my ending vertex there would be 5, 1. And I've got 1, 2, 3, 4, 5, up 1. And let's check to see if this parabola opens up or down. So that's also a -2, which means it also would be a parabola that would open down. So we'll kind of draw a little, if it opens down, it's a frown. Little rhyme for you there. So it ends at this parabola. And I guess what I mean by start and end is, and I almost kind of look at a graph like a map of, almost kind of like a street map of saying, if this was your house and this was your buddy's house over here, and you wanted to get from your house to their house, how many streets would you have to go up and how many streets would you have to go over? Well, if you take a look at this, you would have to go up 1, 2, 3, 4, and then right 1, 2, 3. So again, that was up 4, right 3. So our answer here would be up 4, right 3. And actually, the order doesn't matter. You could have also said right 3, right? Because you could have gone 1, 2, 3 to the right, and then up 1, 2, 3, 4. So, the order actually doesn't matter on that one. All right, so again, let's go ahead and pause the video now, and try number 4 in the middle, and then we'll be back in a second to check your work. Alright, so go ahead and pause the video now. So welcome back. So let's try number 4 in the middle. So number 4 in the middle, you should have got an answer of down 4, right 4. Again, had you had written right 4, down 4, that would have been exactly the same answer. So if you got that as an answer, go ahead and pause the video now and try number 4 on the right side, and then we'll be back in a second to check that answer. If you didn't get the right answer, go ahead and pause, or I'm sorry, not pause the video, stay with us and we'll actually work through the problem together. Alright, so let's go ahead and write. I'm going to write where I start. So y equals 4 times x plus 1 squared plus 2. So I'm calling this my starting parabola. That's where I'm going to start. And let's figure out what the vertex for the starting one would be. And again, where people make a mistake is they either don't switch or they switch the wrong one. So remember, it's the one the h value, the one that's on the inside that switches. So that positive 1 would actually be a negative 1. So remember, we're taking the opposite of that. And then the k value, right, which represents the y of the vertex, stays the same. So that would be a positive 2. So negative 1, 2 would be my starting vertex. Negative 1, 2. So I'm at negative 1, 2. So left 1, up 2. And there's my first parabola. Well, actually, we haven't drawn it yet. Maybe let's figure out what we got a positive 4 there. So the positive 4 means we're going to, since it is positive, because again, we're referring back to this right here, up or down. The A tells you up if it's positive, down if it's negative. So he's happy, so we're going to draw a smile. And again, we're just sketching it there, so we've got a parabola that looks like that. Now, let's look at the second one. So we've got y equals 4 times x minus 3 squared minus 2. So same deal. The x value, take the opposite. So negative 3, we take the opposite, would be a positive 3. Right, that's opposite. And then the y value stays the same. So negative 2 just stays negative 2. Stays the same. And so there's my vertex. And by the way, one word that we haven't used yet, vertex, just refers to the turning point. So it's the point on the parabola where, so you see it's going down, 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 and then it turns back up. Or in the case of, let's see, like on this one, right? So, or a parabola could be going up, 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 and then it goes back down, right? So either way, that's what we refer to as the vertex. And a vertex that has or a parabola that has a vertex as its lowest point, we call that vertex a minimum. And then a parabola that has a vertex as its highest point, we call that a maximum, because it's the maximum height. It's the highest point. All right, so let's graph the other one. So you got 3, negative 2. So let's go right 3, down 2. And check if this guy's happy or sad. It's also positive, so that also would be a parabola that opens up. So let's draw a parabola that opens up. And again, this was my starting place, and you know, make sure that you do that on your paper, so that way you don't get the two confused, right? So that's where you're starting, and then this is where you're ending. Right, so this is where you're ending over here. So then if we count the distance, right, so that would be down 1, 2, 3, 4. 1, 2, 3, 4 to the right. So down 4, right 4, which is where we got that as an answer. All right, so pause the video now. Try number 4 on the right side by yourself. And if you have already done it, let's check to see what you got. So what you should have got for number 4 on the right side is you should have got up 6 and right 6. So take a look. If you got it wrong, take a look, see what you maybe did wrong. If not, let's move on to number 5. So number 5 is actually also another graphing question that's in vertex form. So let's take a look at it. So it says if the graph of the equation, then they give you an equation, and I'm just going to rewrite it so I've got a little room to work here. Y equals 1/3 x minus 3 squared plus 2. And then it says if it's shifted, one unit to the right. So if you shift something, you're moving something. Well, let's figure out where it would be, before it gets moved, because it sounds like they're moving this thing somewhere. So let's figure out at least where it would start off at. So if we, again, the -3, we've got to take the opposite, so that would become a +3. The y value stays the same, so that +2 would stay a +2. So we have a vertex at 3, 2. That's going to be our starting vertex. So 1, 2, 3, and then up 2. And then let's take a look. So it's a positive. So we said that a value, that first number, that tells you whether the parabola is going to open up or down. Since it's positive, that parabola is going to open up. So we know that it's going to open up. But there's one other consideration that we have to make, and it was actually a consideration that we didn't necessarily look at on number 4. There's one other thing that A tells you. A tells you up or down, but it also tells you how narrow or wide the parabola is going to be. And let me show you what I mean by that. So for instance, let me just show you what we call the parent function or the mother function. Right? Y equals x squared is the most basic parabola. So that's a parabola that starts at 0, 0, and it's got a normal width. Look what happens when I throw a number in front. So our a value, so let's say a is equal to 5, and I just throw a 5 in front of there. Notice what happens is the parabola got more narrow. It kind of squeezed in. And if I put a 10, you would expect that since that number is even larger, that it would just squeeze in even more. And then so you see it squeezes in a little bit more, right? Which is that maybe kind of hard to see, but it's that innermost parabola that's there. So what ends up happening is that if a is greater than 1, then the parabola becomes more narrow. Well, what do you think happens if a is less than 1? Well, so let's experiment with that. So let me go back to my mother function, clear these two out. Let's do something less than 1. So for instance, and this is actually like what we have in this problem. We have 1/3. So let's try 1/3 as our a, and then see what happens. So x squared. We'll graph that. So there's mom. Oh, okay. Notice 1/3. See, now it widens out. So if a is less than 1, that becomes a parabola that is more wide. And you would expect if I tried something, even smaller, let's say 1/10, instead of 1/3, let's say 1/10. Again, you would expect this to be a parabola that would be even wider, and as you see, it's even a wider kind of parabola there. So that's the pattern with it, a bigger than 1, and it's kind of opposite of what you might think. You'd almost kind of think that maybe the bigger the number, the wider it gets. It's actually somewhat the opposite of that. All right, so what we're saying is that there's 3, 2, and then we're saying it's a parabola that's a little bit wider. And what exactly does wide? Again, we're just kind of sketching it, so it doesn't have to be perfect. I'm just drawing a parabola that's a little bit wider. And then what it's saying, though, is that if you shifted 1 unit to the right, so if you took that parabola, you picked him up, and you moved him over 1, what would that look like? Well, what that would look like is instead of having a vertex right there, the vertex would be right there. Now, everything else is still the same. The positive 1/3 means it opens up and it's going to be a wide parabola. All of that is the same. We're just saying if you shifted it over 1 spot, where would it be? Well, it would be right there. So what would the ending vertex be? Well, that vertex right there would be 1, 2, 3, 4, up 2. So our new vertex would be 4, 2. It opens up because that number is positive, and it is wide because this number is less than 1. A is less than 1, so that means that it is wide. All right, well, so pause it, try number 5 in the middle, and then we'll be back here in a second to see what you got. So for number 5 in the middle, should have got a starting vertex of 2, -4, an ending vertex of 0, -4, with a parabola that opens down and then is more narrow as compared to y equals x squared, our mother function. So if you got that, great. Pause it now. Try number 5 on the right. If you didn't get that, well, let's go through it together and figure out what happened. So again, I'm going to rewrite it. Just give myself a little room here. Y equals -3 times the quantity x minus 2 squared, minus 4. And let's figure out what our vertex is. So again, the x value, we're just going to take the opposite. So that negative 2, take the opposite. That would become a positive 2. And for the y value, that negative 4 stays exactly the same. So that would be a positive 4. I'm sorry, negative 4. Negative 4, right? Because remember, it stays exactly the same. So negative 4 stays a negative 4, which is where we got a starting vertex of 2, negative 4. And then what it's saying is that it shifted. Let's see how it shifted. Shifted 2 units to the left. So we're at 2, negative 4. Let's do a parabola at 2, negative 4. Right? Because this is where I'm starting at 2, negative 4. Which would be right 2 and down 4. 1, 2, 3, 4. All right, there's my vertex. And let's check out how it opens. So let's see if it opens up or down. Well, that's a negative 3, so that means that's a parabola that's going to open down. And it's greater than 1, so that's going to be a parabola that's a little more narrow. So we'll draw that one a little bit more narrow. And then what we're saying is if you shifted it 2 units to the left. Well, if you shifted it 2 units to the left, pick them up and move them over 1 over 2, there we are. And that would be our new parabola. So what would that new vertex be? Well, it's actually on the x, or the y-axis rather. So you'd go straight down, so that would be 0 and negative 4. It opens down, and it is narrow. Down because it's negative. Right? All the negative tells you is up or down. It doesn't tell you wide or narrow. The negative just tells you up or down. It's the number that then tells you wide or narrow. And since that a is greater than 1, then it's going to be something that is more narrow. All right, so pause it now, and let's try number 5 on the right side. And welcome back. So let's check number 5 on the right side. So you should have got a starting vertex of negative 2, 3, ending vertex of 1, 3, a parabola that opens down and is more wide as compared to the mother function. All right, so let's move on to number 6. So number 6 says, what is the maximum value of, and then it gives you something. Well, first of all, one thing that we should clarify here is that you might notice this thing that says f parentheses x, that's actually f of x. It's function notation. You may or may not have seen that before. Just make a little note to yourself here. F of x means the same thing as y equals. So it means exactly the same thing. So what I could do is I could just substitute this. I could say y equals negative 2x squared minus 4x minus 6. Again, you might have seen function notation in another course in Algebra 2. At this point, we actually have not discussed function notation, so we'll come back to it. But so for now, just know that that means y equals. It says what is the maximum value. So again, the maximum value, that's another word for what is the vertex. So circle that, and let's make a note to ourselves here. It's just another word for the vertex. They're just asking us to find the vertex. Remember we said that a parabola that has its highest point, and I don't know if that's exactly what this one looks like, but we could say that that would be the highest point, so that vertex would be a maximum. And you know it's a frown, it opens down, right? Because you see that negative right there. All right, so this is not in vertex form. So it's not, you notice it doesn't have the parentheses. It doesn't look like the last one. This is standard form. So when it is in standard form, we've got a little formula that we use to help us figure out what x is equal to. So it's x equals negative b over 2a. It's kind of like the first part of the quadratic formula, just not the plus or minus square root of b squared minus 4ac part. So it's just the negative b over 2a part of it. And so let's identify our a and our b. So there's our a, there's our b. And then so what you'd have is that this says the opposite of b, which again b is a negative 4, over 2a, which a in this case is negative 2. And so a negative and negative, and actually I'm going to go ahead and make that a positive right here. Right, the negative and negative actually makes a positive 4. And then 2 times negative 2 would be a negative 4. So I get negative 1. So what that is that that's my, as far as my vertex, because again the vertex is just x comma y. And by the way, I'm not graphing here. They just want to know, what is this point, right? What is that point right there? Well, we know that the x is -1. Now we just need to figure out what's the y. Well, hey, there's y right there. So all we got to do is just plug it in. So I'm gonna rewrite this. So I've got y equals -2, and then instead of writing x, because I'm going to substitute that in, I'm gonna leave a little parentheses. I'm a little blank here because what I'm going to do is I'm going to fill that in. -4 times x, which again I'm going to leave a little parentheses there, -6. So what I'm doing is I'm going to substitute, now that I know that x is equal to -1, I'm going to replace that right there and right there. So I'm going to drop in a -1. And so let's see what we get here. So you've got -2. And by the way, so let's do a quick talk about order of operations here. Please excuse my dear Aunt Sally. We do exponents first. So -1 squared, right? Because you wouldn't, if you did -2 times -1, you get a +2. +2 squared would be 4. But we do exponents first. So do this part of it first, -1 squared, which would be a +1, and then +1 times -2 would be a -2. -4 times -1 would be a +4, and then -6. All right, well, -2 plus 1 would be a -2. And then -2 plus 4 would be 2. And then 2 minus 6 would be a -4. Well, so there's your x and your y, right? So this was our x, and then this was our y. So the vertex would be -1, -4. And again, no graphing on this one. They actually just wanted to know what the vertex was. All right, so go ahead and pause the video now. Try number 6 in the middle. All right, well, let's check number 6 in the middle. So for number 6 in the middle, you should have got 1, -1. If that's what you got, great. Go ahead and pause the video now. Try number 6 on the right side. If you did not get that, then let's work through it together to figure out maybe where the mistake was. Well, the first thing, just so I don't get confused, I'm going to just rewrite this as y equals -2x squared plus 4x minus 3, because again, we're not using that function notation. There's my a, there's my b. -3 is my c, but you notice in the formula it's just -b over 2a, so I don't need to know the full thing there. So x equals -b over 2a, which would be a 4 there for my b, over 2a. The a is a -2. And so let's simplify that. So -4 divided by -4, which would be a +1. Right, so that's where we got the +1 from right there. And then now what we're going to do is we're just going to substitute that in. So I'm going to rewrite it. So -2, but what I'm going to do is I'm not going to write the x. I'm just going to leave a little spot there where I'm going to plug in that +1. All right, and -3. So let's do that substitution. So I'm going to drop off 1 right there, and then I'm going to drop him off right there. So there's a 1 and there's a 1. So y equals -2. Again, you do your exponents first. So 1 squared, which would be 1, plus 4 times 1, which is 4, and then -3. And you could do a little bit of this mentally. I'm just kind of showing you, the steps on this. -2 plus 4, which would be 2. 2 minus 3, which would be a -1. So that would be my y value. So the vertex would be at 1, -1. All right, so go ahead and pause the video now and try number 6 on the right side. And if you are ready to move on, let's take a look at number 6 on the right side. For number 6 on the right side, you should have got a vertex of 2, 9. So again, if you did not get that correct, take a moment, try to figure out maybe what your mistake was. And if you're not able to figure that out, well, then there's nothing wrong with asking for a little help. Otherwise, let's go ahead and take a look at number 7. So number 7 says, what are the x-intercepts of the graph of y equals 2x squared minus 2x minus 1? Well, what they're asking us there, and maybe we can kind of go back to our graph, clear out these parabolas, is that if we graphed it, so they want to know what are the x-intercepts. If you graph 2x squared minus 2x minus 1, what are the x-intercepts? Well, let's graph it. So there's the graph. So what does it look like? It looks like it's crossing in between 1 and 2. So that's where maybe we get an answer that's a fraction. And then it also looks like it's crossing between 0 and -1. So also a number that's going to be a fraction. So I actually don't see a whole number there. So what we're wanting to know is what are those 2 points? What is that point? And, well, what is that point? Well, so they're asking us to solve. We said in the beginning, to solve is the same thing as finding the x-intercepts and vice versa. So we just need to solve this thing. So if we're going to solve, they got the y equals on here, like we're talking about the graph, which we are, but when we go to solve it, we need it to be in standard form. So really all you're doing is just throw a 0 on the end of that. Now we want to see, we said first of all, you always want to see if you can factor first. So if you tried to factor this thing, I don't know, what would you get? Let's try 2 times -1, which is a -2. -2 on the bottom. So we're looking for 2 numbers that multiply to -2 that add up to -2. Well, the only way you can multiply to -2 would be -2 and 1, or 1 and -2, or -1 and 2, I should say. And neither way though, that ain't gonna add up to -2. So right, so you can't factor this. This cannot be factored. Oh no, what do we do if we can't factor? Oh, that's right. We got the quadratic formula coming in to save the day. So let's label our A, B, and C. So there's our A, and here's our B, and then here is our C. And same drill. You don't know if you're going to get a perfect square, or you're going to get a positive, you're going to negative, who knows? So you just got to kind of get in there and then see what happens. Plus or minus. So -2, which is my B. And again, hopefully you're not having too much problems with this part of it. Hopefully the plugging in the number part of it, hopefully you're feeling pretty good about that. If anything, it's maybe at the very end where we have to try to simplify the radical. So let's see. B squared, which would be -2 squared, times 4 times A, which is 2, times C, which is a -1, and then that's all over 2A. And again, I've color-coded it for you here just so you can keep track of everything in black. That's the part of the formula that's always there. So for instance, this will always be squared. This will always be a +4. So those are the parts that are always there. Now, -2 squared, which would be 4, minus, and then let's see what's in the parentheses here. 4 times 2 is 8. 8 times -1 would be a -8. Oh, okay, so what we see here is actually the negative and negative would make one big plus. Similar to what happens out front. That negative and negative also makes one big plus. Well, 4 plus 8 is a +12. Those 2 other problems, numbers 2 and 3, we actually got a negative. Well, actually, here we're getting a +12. So that means we actually are getting an answer, which means we are getting something that does cross the x-axis. Well, we can clearly see that there's 2 points there. Something between 1 and 2, and something between 0 and -1. So let's see if we can figure out what that is. Now, 12 is not a perfect square, so what I'd have to do is kind of go to the side, similar to what I did before, do a little scratch work here. So 12. Now, there's no I business here because, well, there's no negative. So you would just take 12 and pull them apart. Pick the pair that has a perfect square. If you did 2 and 6, well, 2's not perfect, 6 isn't perfect. Oh, 4 and 3. Yeah, so let's do 4 and 3. And again, when you do this factor tree, make sure that you keep the radicals on there. A radical only comes off once something is a perfect square. So for instance, square root of 4 is 2. The radical comes off. 3, not a perfect square. So that's all we can do with that, and 3 can't be broken down any further. So I would have 2 radical 3. As was the case for the other one, every time really you do the quadratic formula. What's out front, what's on top, what's on the bottom. And then so let me rewrite. So I've got a +2 plus or minus 2 radical 3 over 4. Now we're always looking to reduce to see if we can. Maybe we can, maybe we cannot. In this case, we actually can reduce. I can divide everything by 2. So I'll divide by 2, divide by 2, and divide by 2. And when I do that, I get 1 plus or minus. Again, 2 divided by 2 is 1. 1 radical 3 is really just the same thing as radical 3. and then 4 divided by 2, which is 2. And by the way, you might be wondering, okay, well, so if that one disappeared, why not the one that's in front? Well, that one that's in front, that has to be there. If you took that away, you would be changing the problem. But see, 1 times radical 3 is the same thing as radical 3, so that doesn't change the problem. All right, so we're almost there. Thanks for hanging in there. We're at number 7 in the middle, so go ahead and pause it now. Let's see what you got, and we'll check back with you here in a second. But actually, before we move on, I did want to clarify one thing, is that, so when you look at this, because you said, well, the whole point of this was for us to see where the parabola crosses the x-axis. We said it was somewhere between 1 and 2, and between 0 and -1. And then you're like, but what's that? How's that an answer? Well, what this answer is saying is that we said, well, it crosses in between. It's not a whole number. It's a decimal. So what we do is we don't want to have to write out the 1.245 blah, 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 whatever the decimal is. So we just leave it as a fraction. It's cleaner to leave it this way. If we actually typed into a calculator, if we said 1 plus the square root of 3 divided by 2, then we would get some number in between 1 and 2. So there still is a connection there. I know that's kind of a weird looking answer, but it's just that the answer would be a decimal, that's all. All right, so let's look at number 7 in the middle. So for number 7 in the middle, should have had 2 plus or minus radical 2 over 2. If you got that as an answer, great. Go ahead and try number 7 on the right side. If you did not get it, hang in here with us, and maybe we could check to see our work and maybe see where the mistake was. So I'm just going to rewrite it first of all. 2x squared minus 4x plus 1 equals 0. So let's try, here's my A, here's my B, and here is my C. And so I'm going to set it up. X equals negative B plus or minus the square root of b squared minus 4 times a times c all over 2a. Sometimes I set it up this way where I just, because I know that's the part of the formula that's always going to be there, and then I go back and fill in my numbers. So negative b, which would be a negative 4, which by the way, right away you see the two negatives. Make those a plus. B squared, which is also a negative 4, minus 4 times a, which is 2, times c, which is 1, and that's all over 2a, which is 2. All right, well, let's simplify. Let's make our cake. Simplify what's underneath the radical. Negative 4 squared, which would be 16. Again, that's negative 4 squared, not negative 4 times 2, minus 4 times 2, which is 8, times 1, which would be 8. So 16 minus 8, you get a positive 8. All right, so 8's not a perfect square, so let's maybe go to the side, do a little scratch work here. So the square root of 8, if I broke that apart, well, there's only one way to break it apart, which would be 4 and 2. The square root of 4 is 2. 2 is not a perfect square. 2 cannot be broken apart any further. So I would have 2 radical 2 as my little cake topper. Right? That's what it is, just a little cake topper. And then what do we have for our answer? Well, again, what's out front? What's on top? What's on the bottom? And let's see what we've got there. So we would have 4 plus or minus 2 radical 2 over 4. Can we reduce? Sure, we can reduce. Let's divide everything by 2. Seems like we've been doing a lot of dividing by 2. It's not always that you would divide by 2. It just seems like that's what we've seen here. 4 divided by 2, which is 2. 2 divided by 2, which is 1. The 1 goes away, right? Because 1 radical 2 is really the same thing as just radical 2. 4 divided by 2 is 2. All right, well, so if you hadn't tried number 7 on the right side, then go ahead and pause the video here to give you a chance to try number 7 on the right side. Otherwise, if you've already got it and you're wanting to see what you got for your answer, let's check it. So what you should have got for number 7 on the right side would be 1 plus or minus radical 10 over 3. Again, if you got the right answer, let's go ahead and go to the next one. If not, pause it here, try to figure out your mistake. If not, ask for help. Number 8, that's another graphing one. So we're back to talking about some graphing. So it does kind of go back and forth between solving and graphing. We say those are our two major themes. But this one's actually going to be pretty easy. This is actually easier than the other two, because the other two is like, hey, graph it and then pick it up and move it over here. Where would it be now? This is actually just straight up graph it. No graph and then move it. It's just graph it. Okay, well, I think that should be a little bit easier. So let's start with our vertex. Again, we know that this would be the opposite right? That would be the opposite, so that would be a positive 4. And then we know that this stays the same, so that would stay a positive 1. So there's our same and opposite. So our starting vertex on that one would be 4, 1. Well, I say starting. I mean, there's only one parabola here, so that is our vertex. So we've got a vertex at 4, 1. Let me go over here. 1, 2, 3, 4. Up 1. And then, let's see, does it open up or down? Well, let's check our A. Remember, A tells us that. A tells us if it's positive, it's going to open up. If it's negative, it opens down. So I've got a positive 2, which means that it's going to open up. And it opens up because A is positive. If you were checking, so the A is greater than 1, actually it would be a little more narrow as compared to the mother function. But that's actually not really asked of us here. Not too worried about that on this particular one. But yeah, it would be a slightly more narrow parabola. All right, so pause it here. Same drill. Try number 8 in the middle. All right, well, let's check number 8 in the middle. So for number 8 in the middle, should have had a vertex of -5, -3. Again, remember, you got to do the opposite there. So that positive 5 becomes a -5. And again, that -3 stays the same, right? -3 just stays a -3. So again, opposite and staying the same. So that would be a vertex at -5, which means left 5. Down 3, so there's our vertex of -5, -3. And let's check A. So A tells us again up or down, and since A is a -2, that means the parabola, oh, he's so sad, poor guy. So he's going to open down, and again, we're not worried about more narrow or wide, but again, since A is greater than 1, it would be a little bit more narrow. And then for number 8, so you should have a vertex of 3, 4. So again, same idea here. Switch the x value, right? So that becomes a +3. The other one stays the same. So +4 stays +4. So you have a parabola at 3, 4, which means right 3, up 4. So there's our vertex. And then let's check A. So A tells us on this one, again, up or down. And actually, that's, by the way, we hadn't mentioned that, or maybe I haven't mentioned that yet, is that that's actually the same for vertex form and standard form, is that the A tells you whether the parabola is going to open up or down and whether it's narrow or wide or not. You have a -2 right there, so that tells you the parabola is going to open down. And again, it's a little more narrow as compared to the mother function. All right, well, let's move on to number 9. Almost there. We just got 2 problems left, so flip on over to that back side. And we'll take a look at number 9. So number 9 says sketch the equation of the graph 4, and it says y equals x squared plus 2x minus 2. Now I know what you want to do. What you want to do is you want to do this. You want to say, oh, okay, well that would be a -2. That stays the same. So that would also be a -2. Oh, but here's the deal. And don't write that, by the way, because it's not correct. You can't do that because it's not in vertex form. You can only do that when it's in vertex form, which in this case it is not. It is in standard form. So we do not get the vertex for free. So let me get that out of there because that is not correct. How we figure out the vertex is we have to use our little -b over 2a. That's how we figure out what the vertex is when it is in standard form. All right, so let's take x equals -b over 2a. And, well, let's identify what our A, B, and our C. Oh, actually, we don't even need to know C, right? We just need to know A and B. So there's your A, which is a -1. There's your B, which is a +2. Actually, I wanted to do that in a different color. So let's see. -A, which is a -1 over 2A, which is 2. And what we end up with there, all right, I know you're shouting at me saying, hey, wait, that's not right, that's not right. You'll have to forgive me. It's a little late on a Sunday night. I've been at this for a little while. So, yeah, we actually got the numbers a little switched up here. So let's fix this. I knew that wasn't looking right. So -b, so that should be a +2. We got those little mixed up there. And then a -1. And that's, I think with this quadratic formula, all this stuff, it's really easy to, to plug in the number, wrong number in the wrong spot. So, if you're not getting the right answer, again, I don't just give up and think that you don't know what you're doing. You probably just made some silly little mistake like that. So, in the end, it's actually kind of a good thing that you see me make that mistake, because you're going to make that same mistake at some point, right? So we just want to be careful there. All right, now that we're back on track, so our x is 1, and so remember, now we just got to figure out where y is going to be. So I'm going to copy my equation. So I've got a negative 1 x squared, and I am writing that negative 1, and you'll see why here in a second, plus 2x minus 2. And again, I'm just going to substitute. I'm picking up x, and I'm going to put him in right there, and put him in right there. So I'm going to rewrite this where I've done the substitution, so that would be negative 1 squared plus 2 times x minus 2. And there we go. And so you get y equals 1 squared. By the way, again, order of operations. You got to square this first. If you multiply then square, you will get the wrong answer. So you got to square it first. So this would be a 1 squared, which would be a positive 1, plus 2 minus 2. So that would be negative 1 plus 2 minus 2. Well, negative 1 plus 2 would be positive 1, and then, and then 1 minus 2 would be a negative 1. So we'd get y equals negative 1. So that would be my vertex. So my vertex would be at 1, negative 1. So I've got 1, negative 1 for my vertex. There's my x and my y. So 1, negative 1, my parabola would be right there. And then let me just get a feel for what this would be. Actually, my a is 1, so that's actually the standard in the middle width, not wide, not narrow. And then all we really got to do is just focus on, which way does this thing open? Does it open up or down? Well, remember, we said that a actually serves the same purpose, which is that if it's positive, it opens up. If it's negative, it opens down. Well, let's take a look here. That's actually a negative 1, so that means that it's a parabola that opens down. So we have a parabola that looks something like that. All right, well, almost there. Pause it here. Try number 9 in the middle, and then we'll be back here in a second to see what you got. Okay, so you should have done number 9 in the middle at this point. So let's see what the answer is there. So you should have got a vertex of 2, 3. 2 for your x, 3 for your y. So that would mean right 2 up 3. And the a on this one is negative. So that would end up being a parabola, right? So you got a negative a right there. So that is a parabola that would open down, since that is negative. And if you got that right, great. So pause it here. Try number 9 on the right side. If you didn't get that correct, let's double check that together now. Maybe we can figure out what mistake you made. So first thing, by the way, I would do is I would plug in a 1 right there. So there's my a, and then here's my b. And then I'm just going to write x equals, and again we're using same formula over here, negative b over 2a. So x equals negative b, which would be a negative 4 over 2a. And again, our a here is a negative 1. So negative 4 divided by negative 2, which would give you a positive 2. So that's where we're getting the positive 2 from. And then let's see where we got the positive 3 from. So I'll rewrite y, and that'll be a negative 1x squared plus 4x minus 1. And then again, I'm going to do a substitution here. So I'm taking 2, dropping him off right there, and then dropping him off right there. So I've got negative 1 times x squared plus 4. And again, I'm just leaving in a little spot for where I'm going to drop in that 2. Order of operations. Please excuse my dear Aunt Sally. Remember, we always want to do exponents first. So 2 times 2, which would be 4. So I got negative 1 times 4, plus 8 minus 1. And negative 4 plus 8, which would be 4. 4 minus 1, which would be 3. And a positive 3. So that's where we got that from. And again, as far as on the parabola, right? So as we said there, kind of in the beginning, your A is a -1, so that's why the parabola opens down. And would be of a normal width, but again, that wasn't really a factor on this one. All right, so pause it now. If you hadn't already tried number 9 on the right side, go ahead and pause it now. Give it a shot. Otherwise, if you have it done, let's move on together and see what you got. So for number on the right side, you should have got a vertex of 3, 5. So 3 to the right, 5 up, there's your vertex. And again, same situation here. You have a that's negative, so it's going to be a parabola that opens down. All right, so the finish is in sight. We're almost there, number 10. Thanks for hanging in there. So this says how many times is the graph of, and then it gives you, it gives you a equation there. How many times does it cross the x-axis? Well, so what they're saying here is that there's there's a couple different ways that you could see this. Is that, first of all, and this was a parabola that we had graphed a couple problems ago. You see how it touches in 2 places. So if the question was how many times does this touch? Well, it touches twice. But you could also have a parabola, and I'll just throw one up here for you real quick. You also could have a parabola that maybe only touches in 1 place. And we also looked at the situation. See how that parabola, it just kind of dips down, touches in 1 place, and then it bounces back up. So that would be a parabola that only touches in 1 place. And then, of course, we looked at some parabolas earlier that didn't touch at all. That's when we had a no real solution. That's where the imaginary numbers come in. So basically, this is just another way of saying, hey, solve this and see how many answers you get. Okay, well, so I'll solve it. How do we solve? Well, factoring or by using the quadratic formula. Again, we're always checking to see if you can factor something first. And by the way, as far as checking for standard form, if you notice here, really this is in standard form. We just need to throw the equals 0 on the end of it. Actually, let me move this real quick. So I would just rewrite that as 4x squared plus 16x plus 15 equals to 0. And then we can factor it from there. So let's factor it. It's a times c and then b. So we're gonna factor it next. And this is very similar to the first problem that we saw on the study guide. So, and by the way, you still label your A, B, and your C. So as far as A, B, and C, there's my A, there's my B, and then here's my C. So A times C would be 4 times 15, which would be 60. So there's 60, and then a 16 on the bottom. All right, we're looking for 2 numbers that multiply to 60 that add up to 16. Well, that would be 10 and 6. And let's put those in parentheses. So we would have x plus 10, and then x plus 6 equals to 0. Now remember, we have to divide by a. Right, so that's not quite our factor just yet. We have to divide by a. So our a is 4. So we're going to divide by 4. And so Beyonce's telling us up there, if you can't divide it, slide it. Well, what's a little different about this one, you notice that actually neither one of them divide evenly. Well, so what happens is that if neither one divides evenly, part of dividing also means, can you reduce it? Is this a fraction you can reduce? Well, so don't slide it yet. Don't say 4x plus 10 and 4x plus 6, because this fraction can be reduced. So let's reduce this fraction first, and then we're going to do some sliding. So this would be x plus 5 halves and 3 halves. All right, so now can't divide evenly, can't reduce it any further. So now this is where, if you can't divide it, slide it. So we're going to slide that 2 over, and we get 2x plus 5, and then 2x plus 3 equals 0. So this is where we're going to separate and solve it. So we're going to solve these two things. So we need to pull them apart. So 2x plus 5 gets his own equation, 2x plus 3 gets his own equation. And as we said, that would be equal to 0. And then 2x plus 3 equals 0. And then we're just going to solve. So let me scoot down, give ourselves a little more room here. So we're going to subtract by 5, subtract by 5. So 2x equals negative 5. Divide by 2. So we get x equals negative 5 over 2. And divide by 2. So we get x equals negative 3 over 2. So we actually have two solutions there. We have x equals negative 5 over 2, and we have x equals negative 3 over 2. Those are our two solutions there. Now, what does that mean? So, actually, and so how many answers do we have? Well, so actually, let me take back my box, because the way that this question is going to be asked of you on the test is it's going to say how many solutions. Is there one solution? Is there two solutions? Is there three solutions? Which actually there will never be three solutions. And so what we would say in this case is, well, there's two different answers, so there would be two solutions. And we could actually verify that on the graph, because see, if we graphed it, let's go back to our calculator here. If I graph this, 4x squared plus 16x plus 15 plus 15, let's graph that. Okay, so there's our parabola. So you see how it touches in two places. It actually touches both on the negative side, which that should make sense as to why we have a negative and a negative. And then you see how one of them's in between -1 and -2. Right? Well, that's what that one is. And then one of them's in between -2 and -3. Well, that's what that one is, right? That's what our other root is. So that's why we would say that you have two solutions there. All right, so pause it. Almost there. Try number 10 in the middle, and then we'll check back with you here in a second. All right, well, let's check those last two answers for number 10. So, again, you should have already done number 10 in the middle, so we're just now checking our answer. So for number 10 in the middle, you should have got x equals -1/2 and x equals -3 over 2. So you would have had those two for an answer, and so because there are two different answers, or two different values for x, that means you'd have two solutions. So go ahead and pause video now if you did get that correct. Try number 10 on the right side. If you did not get that correct, let's work through it real quick to see maybe what happened. So a times c, right? A times c in our b. So 4 times 3, which would be 12. B, which is 8. Two numbers that multiply to 12 that add up to 8 would be 2 and 6. And then let's put those in parentheses. So we'd have x plus 2 and x plus 6. And that would be equal to 0. And so we need to divide by a. And so again, in this case, our a, right, because there was our a, b, and our c. So our a in this case is 4. Let's divide by 4. And it's the same situation as kind of the last one, where we have to reduce this fraction down. So if you reduce down 2 over 4, that fraction would reduce down to 1/2. And then 6 over 4 would reduce down to 3 over 2. Now we can slide it. So let's slide it. Because, again, you can't divide evenly. You can't reduce it any further. So we would have 2x plus 1 and then 2x plus 3. And that would be equal to, let me move this over, that would be equal to 0, because it's always equal to 0. Now, let's split it apart. So each parentheses gets its own equation. So that would be 2x plus 1 equals 0. And this would be 2x plus 3 equals 0. And then again, we're just going to solve for each one of them. So let me scoot this down a little bit, give ourselves a little more room. And hopefully, in this part, there shouldn't be any problems with this part of it, so you should be all right there. So subtract 3, divide by 2, and then so those are our answers right there. -1/2 and -3 over 2, right, which is what we got right there. Now, again, since there's two separate answers, that's why we say that there's two solutions on that one. All right, and number 10. Oh, by the way, if you hadn't done number 10 on the right, I was kind of in a hurry to move on to the next one because we're almost there. So if you haven't done number 10 on the right, go ahead and try it. If you have, let's check it. So for number 10 on the right, you should have got that there was one solution. The reason why there's one solution on this one is because if we said how many times does this parabola cross, and I got the graph of it pulled up there for us, right? So for y equals 4x squared plus 4x plus 1, if we graph that, you notice it actually only touches at one spot right there, like it dips down and only touches at one place. And it touches in between 0 and -1. Where does it touch between 0 and -1? Well, at -1/2. That's the significance of that number right there. So that is a parabola that only touches in one place. And so since it only touches in one place, there would only be one solution. And, it kind of is a shortcut. If you would have factored it, you would have had 4 and 4. When these numbers are the same, that means that it's a situation where it's actually a perfect square trinomial, which means that it only crosses in one place. All right, well, if you stuck with us through the whole time, congratulations. I know you might be a little exhausted at this point, but proud of you for sticking with it. Did some good work. So at this point, we'll go ahead and stop the video, and you'll be hopefully ready at this point to retake the test. Hopefully you're feeling good. I'm feeling good for you. So thank you, and we'll see you next time.